MS Ramaiah University of Applied Sciences.
Pump, an equipment that has been in usage from centuries. It is an essential machine right from a common man to large industries. It has been excessively used in irrigation or simply to transfer water from a sump to overhead tanks. In a city, water is being pumped and distributed to all the places from the water treatment plants using high-capacity pumps. Pumps also find extensive application in an industry, be it a small amount of chemical dosage or pumping large amount of water to a boiler. Pumps are an important constituent. Pumps are also used in effluent management. Solid and liquid waste may be formed into a slurry and can be pumped to a point where the waste can be processed. Pumps may be defined as hydraulic machines that convert mechanical energy into hydraulic energy. Hydraulic energy is in the form of pressure energy. Based on the construction and mode of operation, pumps may be broadly classified into two types: positive displacement pumps, rotodynamic pumps. Positive displacement pumps are generally used when high head of fluid is required. In contrast, rotodynamic pumps are used for high discharge. If the mechanical energy is converted into pressure energy by means of centrifugal force acting on the fluid, the hydraulic machine is called a centrifugal pump. The impeller of the pump imparts centrifugal force on the fluid flowing through the casing. The area of the casing near the delivery gradually increases. This reduces the velocity of the fluid, which leads to an increase in pressure. Increase in pressure head is due to the conversion of kinetic head, V square by 2G. Centrifugal pump may be classified according to casing design, number of impellers, specific speed, head, etc. The parts of the centrifugal pump are suction line with suction valve, impeller, casing, delivery line with delivery valve. In a centrifugal pump, the fluid enters axially because of the centrifugal action of the impeller. It imparts centrifugal force on the fluid flowing through the casing. The fluid develops pressure due to the increasing area near the casing. In order to attain high head or high discharge, the pumps may be connected in series or in parallel. A multi-stage pump is the one where multiple impellers are embedded into a single entity. The pressure rise of the fluid takes place in multiple stages. The impeller may be placed on a single or multiple shafts. A multi-stage pump is having one of the two important functions: to produce high head or to produce high discharge. At MSR UAS laboratory, a multi-stage centrifugal pump is installed to carry out the performance analysis of the pump. Before we analyze the performance of multi-stage centrifugal pump, it is required to understand few important related parameters. Priming is a process of filling the pump casing with the fluid to be pumped. If any vapor or air is left in the pump casing, the efficiency of the pump reduces and hence will be incapable to produce sufficient head, because head generated by the impeller will be in terms of meters of air, which will be very small. There are different heads that can be encountered during operation of pumps. Suction head is the vertical distance between the center line of the pump and the liquid level in the suction sump. Delivery head is a vertical distance between the center line of the pump and the liquid level at the supply point. Static head is nothing but the vertical difference between the liquid levels at the source and delivery point, or in other words, it is the sum of suction and delivery heads. Friction head is the total head loss due to friction in the suction and delivery lines. The sum of the static head HS, friction head HF, and the velocity head in the delivery pipe is called as total head. Manometric head HM. The difference in total head across the pump, or it is the head against which the pump should work. HM is equal to total head at the outlet of the pump minus total head at the inlet of the pump. Vapor pressure is the pressure exhibited by the vapor present on the surface of a liquid or solid. If the fluid pressure drops below the vapor pressure, more vapor molecules escape from the surface and vice versa. Cavitation is an important phenomenon wherein vapor bubbles of a flowing liquid is formed in a region where the pressure of the liquid falls below its vapor pressure. These vapor bubbles collapse into region of higher pressure, causing even high pressure at the point of collapse. Pitting action is formed on the metallic surface of the pump, experiencing these vapor collapse, and thus cavities are formed. Cavitation causes damage to the pump, increase noise and vibration, and reduction in efficiency. Net positive suction head NPSH is defined as the difference between the absolute pressure head at the inlet of the pump and the vapor pressure head. That is, NPSH is equal to Pi by rho g plus Vi square by 2g minus PV by rho g. The value of NPSH is to be significantly large in order to avoid vapor collapse and thus cavitation in the pump. Pump operating curve. A pump curve gives information regarding the head developed by the pump for a particular discharge, or it may give us the amount of discharge the pump releases for a particular head. It also contains the efficiency and power consumed by the pump. The point at which the pump is allowed to operate at its highest efficiency is called as the best efficiency point or BEP. System curve. A system head curve is defined as a curve relating the head that must be provided at the pump to the flow rate at that pump location. The points on the system head curve are a property of the system and are independent of the specific pump used. The learning outcomes of the current experiment on centrifugal pumps are to assess the performance of multi-stage centrifugal pump, plot pump curve, that is head versus discharge, and also calculate the pump efficiency. The losses in pump may arise due to the following factors. Head loss of the fluid may occur due to the friction between pipeline and fluid, and also losses due to contraction, expansion, directional change. Fluid leakage may occur within the impeller or also through the gaps of clearances provided for sealing. Disc friction loss may also occur due to friction between rotating impeller and fluid. Friction also exists between the fixed and rotating parts in the bearing and stuffing box, which may lead to power loss in the input shaft. The efficiency of the pump can be calculated as the ratio of the hydraulic power output by the pump to the shaft power. That is, efficiency of the pump is equal to hydraulic power divided by shaft power, that is equal to rho W G QH divided by shaft power, where rho W is the density of the water in kg per meter cube, G acceleration due to gravity in meter per second square, Q is the discharge of the water through the pump in meter cube per second, H total head developed by the pump in meter.
Hello everyone. This is the setup in our turbomachinery lab which we are using to calculate the efficiency of a multi-stage centrifugal pump. The setup consists of a storage tank. In this tank we are going to store the water. From the storage tank we are having a suction line. At the bottom of the suction line we have a foot valve which does not allow the reverse flow of the water back to the storage tank. From the suction line we have a priming valve. Using this we can prime the pump casing and the suction line completely with the water. This is the pump which is being driven by a 5.5 kilowatt electric motor. The pump is having 4 stages: stage 1, stage 2, stage 3 and stage 4. The end of the 4th stage is being connected to a delivery valve. Further, it is connected to a delivery line which comes down to the collecting tank. In the collecting tank we have a piezometer which we can use to calculate the actual discharge of the water flowing through the pump. This is the panel on which we get the parameters, the values of the parameters of different pump readings. The motor is connected to a 3-phase supply which should be indicated with these 3 bulbs glowing on. Here we get the suction pressure that is coming into the pump. The pressure is indicating in millimeters of mercury. The 4 stages of pressures are available over here: stage 1, stage 2, stage 3 and stage 4. The stage 4 pressure will give us the delivery pressure. It also consists of an energy meter which is used to indicate the power consumption by the electric motor. The power consumption is calculated by noting down the time for a particular number of blinks on the energy meter. It also consists an indication which will give the speed of the centrifugal pump. There is a toggle switch. If we put it to the left, it shows the RPM of the centrifugal pump, and if it is shifted to the right, it gives the speed of the Pelton wheel. Let us begin by starting the pump. In order to start the pump, we have to keep the main switch in the on position such that all the 3 indications on the 3-phase is glowing on, and then we start the pump by hitting the green switch. Now the valve is kept in a fully open position. At this position we shall take the values of all the stage pressures and the vacuum pressure on the indicating panel. We can note down the speed of the centrifugal pump as 2900. We can note that the suction pressure is around 160 millimeters of mercury. The delivery pressure or the stage 4 pressure is indicated over here. The value is around 2.6 kg per centimeter square. calculate the power consumption of the electric motor, we need to note down the time for 20 blinks on the energy meter. In order to calculate the actual discharge of the water, we close the butterfly valve of the collecting tank and note down the time required for the raise of water from 5 to 20 centimeters. The second trial of the experiment is taken by closing the delivery valve. By doing so, we create an increased head in the upstream of the valve, and then further readings can be taken on the indication panel. By closing the discharge valve, we have created an increased head which can be seen at the stage 4 pressure. The stage 4 pressure is indicating around 6.2 kg per centimeter square. More number of trials can be taken by closing the discharge valve and noting down the different heads available at the discharge. Also, corresponding actual discharge also should be calculated. By doing so, we can calculate the pump efficiency and also the overall efficiency.
At MSR UAS, we spark your imagination unlike any other.